Alright, this video is on calculating the frequency of light based on wavelength. Now, to recap what we learned last time, we learned about what wavelength is and how it's the distance between the peaks, and that is a property of light. And from that property of light of wavelength, we can determine energy. Well, once we've determined that energy, right, so energy is equal to Planck's constant times the speed of light divided by lambda, or wavelength. Well, once we've determined what the energy is, we can actually plug it into another equation, E equals Planck's constant times frequency. And from that, we can derive this equation, which is energy divided by Planck's constant is going to equal frequency. And this is the equation that we are going to focus on today. So in this first problem, which we are determining the frequency of a photon of light that carries 5.37 times 10 to the negative 19 joules of energy, well, we're going to just deal with this equation right here first, and then rearrange it to be this guy right here. In the next problem, we're actually going to start up at step A, this B, C, and or B and C. Right now, we're just going from B to C. Okay, so this will just be the calculation of a frequency once we have the energy, which is given in the problem right here. Okay, the next problem we do, we're actually going to start with a wavelength, and then calculate the energy, and then from that calculate the frequency. All right, so let's go ahead and take a look at the problem that we have in front of us. We're determining the frequency of a photon of light that carries a 5.37 times 10 to the negative 19 joules of energy. Okay, so I'm going to set the problem up. Energy is equal to Planck's constant times frequency. Now, before we even plug in any numbers, let's go ahead and treat this like a literal equation and solve for the variable that we want. We want to solve for frequency. So if I divide both sides by h, Planck's constant, okay, that means I'm going to end up with frequency equals energy divided by Planck's constant, okay, which is h. So, continuing on, the energy, which is right here, I'm going to put there. So it'll be 5.37 times 10 to the negative 19, and I'm making sure I'm keeping track of my joules right here, right? Over Planck's constant, which is 6.63 times 10 to the negative 34 joule seconds. All right. Now, in this, okay, if you're wondering where I got that 6.63 times 10 to the negative 34, that is a constant. That is Planck's constant, so it's in your notes. Okay, but here I have E over H. My joules in this case are going to cancel out, and I'm left with seconds, but the seconds are on bottom, so my unit is going to be something per second. So when it comes to a frequency, right, when it comes to a frequency, it usually has the unit of cycles per second, right? So that's what your unit is going to be, cycles per second, or you can just go cycles per second. You can write it like that, okay, and that's just fine. So let's go ahead and do the math. So that means my frequency is going to be 5.37 times 10 to the negative 19 divided by 6.63 times 10 to the negative 34 seconds. Okay, so here my frequency is going to be with 3 sig figs, 8.10, because it's 8.099, right? So I'm going to go 8.10 times 10 to the 14 cycles per second. All right, and this would be my frequency. Okay, just in case we're a little confused, this E right here, okay, E is the same thing as saying times 10. Okay, so you're wondering, well, why are you writing E, you know, E here? I'm not quite understanding this E right there. That means times 10 when it's a part of a number. Obviously, this E right here means energy. It's something different in the equation. But this E, these two E's, this E right there, that's a part of a number. and it means times 10. All right? So, let's go ahead and do another problem. In this case, we are going to determine the frequency of a light with a wavelength of 537 nanometers. Now, there's a couple steps to this problem. All right? One, we need to identify what type of information we have. Well, we want to have frequency, and we have wavelength. Okay? Well, I can't go, well, I can, but you don't have the equation to go from wavelength to frequency, so you have to go from wavelength to energy, and then from energy to frequency. Okay? So, if I was to do this, it's going to be a two-step process. Okay? And now there is some algebra right here that if you wanted to try to shorten it up, you could. And at the end of the video, I'll show you how to do that, or at the end of this problem, I can show you how to do that. Right? I know that energy is equal to hc over frequency, right? And in order for this to happen, hc over wavelength, excuse me. And I know that wavelength needs to be in meters in order to have the product of hc cancel out the appropriate unit. Okay, so I'm going to go ahead and do the whole problem out. So I'm going to go 6.63 times 10 to the negative 34 joule seconds. I'm going to multiply that whole number right there by 3.00 times 10 to the 8 meters per second. Okay, so right then and there, what I can do is I can cancel out my seconds. I'll do that. Okay, and I'm going to divide that by 537 nanometers. Well, if I did that, then my this number right here or that unit right there and that unit right there can't cancel out. So I cannot use, okay, 537. I need to convert it to meters. Okay, so off to the side right here, I'm going to go ahead and say 537 nanometers over 1. Then I end up with 1 times 10 to the 9th nanometers, which is a billion, is in 1 meter. Right, nanometers cancel out, I'm left with meters. So when I write this number out right here, which I'll write it in my equation, it's going to be 5.37 times 10 to the negative 9th. Oops, sorry, 7th. So remember, the E and the times 10 mean the same thing. Here I wrote it two different ways, they mean the same thing. So don't fret about that. All right? I'm going to do my equation, or do the calculation, which is going to be 1.99 times 10 to the negative 25th joule meters divided by 5.37 times 10 to the negative 7th meters. Now my meters are going to cancel out, and I'm going to be left with just joules, which is a unit of energy, which is what I want. Okay, so I'll go down one more little step right here, and I'm going to end up with 3.71 times 10 to the negative 19 joules. Okay, now I'm going to take this value, this is my energy value, right? But I don't want energy, I want frequency, right? So, my frequency equation is energy is equal to h, Planck's constant, times the frequency, which I can rearrange this equation to be frequency is equal to E over h. So when I write this out, my energy value, which is this guy right here, is going to go right there. 3.71 times 10 to the negative 19 joules. I'm going to divide that by Planck's constant, which is this same h, that number right there. 6.63 times 10 to the negative 34, okay, joule seconds. Again, leaving my seconds on bottom. My joules will cancel out. I'm left with cycles per second, okay, and I'm going to end up with a final answer of a number of 5 point, in this case, 60 times 10 to the 14th cycles per second. And that is my frequency. All right. If you guys have any questions, make sure you fill in the question box on the spaces below. And if you have any other questions, make sure you ask in class.